Hello friends and welcome to a lecture on CAPE Open Flowsheet Environment. Today we will learn how to simulate a binary distillation column. The example is benzene toluene distillation. So let's start from the very basics. It is assumed that you have installed CAPE Open Flowsheet Environment or COFE, that is COFE simulator, on your computer. Having installed, go to Start. I have Windows 11, so I will type in COFE, and it's a 64-bit computer, so I take COFE x86. And click Cancel. Now, the first thing that we need to do is configure the thermodynamics. The thermodynamics for distillation is going to be UNIFAC. But nevertheless, let's go to Settings, and in the Settings, select Property Packages. Click Add, and then select TEA. Click New, and let's give our package a name. Distillation Example. In the model set, select Peng Robinson. Click Add. Type benzene. Double click on benzene to include it in the compound list. Then again click Add and type toluene. And double click toluene to add it in the compound list. Then click OK. Click Yes to the resulting windows and close this window. What we have done now is configured the thermodynamics for the stream that enter and leave the distillation column. We have not yet configured the thermodynamics of the distillation column. It will come about in a short while. The first thing after this we do is go to File and go to Save As and save the flow sheet. This is very important as it allows you to recover from crashes. This is the most important step one needs to do once you have started and configured the simulation program. After this, click Stream. Again, left click, you get a button here and pull it to draw a stream. Again, left click, and there we are. So our stream, that is the input stream for the distillation column, is ready. Now double click on this stream. Again, you have to use the left click and change the units of pressure, change the units of temperature. The pressure of the input stream is 1 atmosphere. The temperature is, in this example, 90 degrees Celsius. The mole fraction of benzene is 0.4. The mole fraction of the toluene automatically gets calculated, and the flow rate is 5 moles per second. Having done this, let's close this window and run the simulation. So if we click this play button, it will run the simulation. Now the stream has turned green from black. So it means it has simulated the stream. Now let's double click. And as we can see here in the compound flows are in the correct ratio. The phase fraction of the stream is liquid, so that we can infer that the input stream is a liquid. And here we have all the properties which you can discover. Next, let's click on the palette. Now this palette is for the unit operations. Go to Separators, click the plus button, select ChemSep column flash and click the select button. So you get the ChemSep unit for distillation. Bring it near the stream, left click, and it's placed. Take the feed stream and connect it. Once again, double click on the distillation icon, click on edit. Now we get the starting window for ChemSep simulation. So let's name our unit. So we will name it as distillation benzene. You can give any name of your choice. In the operation, if it is simple distillation, keep it selected. Number of stages. Well, since this is a simulation program and not a design program, you have to give the number of stages that you expect the distillation column to have. So this is going to be 20 by default. The system of units, leave it at SI. And the pressure here is 101,325, that is 1 atmosphere. And the thermo that you have to select in this drop-down list is ChemSep. Now, if you wish to change the pressure of the column, let's say I want to keep it to 2 atmospheres. So I type 2 and leave a space and type ATM and press enter. It will automatically calculate the value of 2 atmospheres in newtons per meter square. However, in this distillation, I wish to do the distillation at 1 atmosphere. So I will type 1 ATM. So it selects the correct value of 101,325. Now click OK. This will open the main ChemSep interface. Now first go to operations. Check whether the operation is simple distillation. Check whether the condenser is total liquid product, and check if the reboiler is partial liquid product. Check the number of stages, which is 20 by default, and the feed stage is automatically taken at the center of the column, that is the 10th stage. In this distillation program, one needs to note that the first stage is the condenser and the last stage is the reboiler. Now come to thermodynamics. In the K value, take gamma phi. In the equation of state, which will be the equation of state for calculating the properties of vapor phase and liquid phase, that is density, let's take it as Peng-Robinson and click yes. Now we have to take a model for the liquid phase. So the activity coefficient model is going to be now UNIFAC. The vapor pressure is Antoine, and whenever we have activity coefficient as UNIFAC, the enthalpies will be calculated using excess enthalpy. So we are good to go. Now the last bit that we need to do is go to column specs. Usually it is very easy to converge the simulation if we give specifications which are not very strict. Now the not strict, very strict specifications for converging this software, ChemSep, is you give a reflux ratio and in the bottom you give a boil-up ratio. The boil-up ratio can be taken as 3. After you enter 3 in this window, click enter. Now we are done. Let's close this window. It says, do you want to save the current input in distillation benzene? Click yes. The column configuration has changed. Update COFE icon. Click yes. And close the window. Now we have to draw the top and the bottom streams. So again go to streams, select it, click it here and again click it. This is the top product, select it. Similarly, again take the stream, come on the exchanger, click, drag and click once again, and you have the bottom product. Now as we can see here, we can solve the simulation column. That is the distillation column simulation. It can be done. Now remember here, if we have not given any specifications or if we have missed any specifications, this icon cannot be pressed. If this icon can be pressed or clicked, then it means we can do the simulation and all the specifications for simulation are given. So let's go ahead and do the simulation. Before that, it is always advisable to save. The reason being, if in the simulation it hangs or it crashes, you lose your work. So always whenever you make any changes, it is a good idea to save the simulation. Now let's go ahead and run it. And there we have run the simulation. The input and the output streams, the thermodynamics for the input and the output streams is Peng-Robinson equation of state, and the thermodynamics for calculating the distillation column is UNIFAC. Now if you want to view any stream, you can go on the stream and double click on it. It opens the stream information. As we can see, the top stream has a pressure of 1 atmosphere. It has a temperature of 84.22 degrees Celsius. And it has a mole fraction of 0.79. Similarly, the bottom stream has a pressure of 1 atmosphere, has a temperature of 110 degrees Celsius, and the mole fraction of toluene in this is 0.9977. Now, if you want to study the distillation column, double click on the distillation column. You get this window, click Edit, and you get the interface of ChemSep. Now here, the first page that you get here gives you an overall information of the distillation column. That is, what is the feed condition, what are the flows, what is the top condition, what is the bottom condition. However, we are interested in more specific information. The more specific information would be the mass and energy balance across the distillation column. So here we go to select table, and then afterwards we select mass and energy balance here. As we can see here, we get the mass flows in and out in the streams, and we get the condenser and the reboiler load, which is given here. Condenser load, reboiler load, and the loads are given here. Now these loads are in joules per second. If we wish to know what is the flow profile on each and every tray, go to T/P/flow profiles. There we have it now. The first table is the flow profile in kilomoles per second, and the second table is the flow profile in kgs per second. The important thing to note here is we get the reflux ratio, which is 2 at the top, and we get the boil up ratio, which is 3 at the bottom, the ones we had set. Now if we want to have a graphical view, so click on graphs, and in the graph you have various options. One interesting option would be the liquid phase composition profiles, that is the tray to tray liquid profile. Click on this and we have it. Also, we can have a look at the flow profiles, temperature profiles, and if we wish to have a view of how it was designed using the McCabe-Thiele method, or of course this program does not use the McCabe-Thiele method, but it uses a rigorous tray to tray calculation. But if we want to have a look at the McCabe-Thiele diagram, click and we get the McCabe-Thiele diagram for this distillation unit. So let's close it. Click yes. Do you want to save the current input in distillation benzene? Click yes. And run it once again. Now, if you want to have an overall picture of the flows going in and out in the distillation column, go to Insert, go to Stream Report, click anywhere on the flow sheet, select all the 3 streams by selecting the first one with your mouse, then press Shift, select the second one and select the third one. Press this yellow button here, which points towards the right, and you have all the 3 streams. Now in the overall props, you will get what are the properties that will be displayed in the table, that is pressure, temperature, flow and composition. That should be enough for us. Click OK. And there we have a small table which gives you an overall picture of what are the flows and the compositions in and out in various streams. Let's say we want the top concentration as 0.99 benzene and the bottom concentration we are satisfied with 0.99 toluene. Of course, if we want this, the reflux ratios will change. Do we change the reflux ratios and do the simulation? The answer is no. There's an easier way. Double click on the distillation column. Click Edit. Go to Column Specifications. Now go to Top Specification and select Mole Fraction of a component. A window opens on the bottom and we have benzene in this drop-down window, which is the compound we want on the top chiefly. So enter its composition, that's going to be 0.99, and always after you enter in this window, press Enter button on the computer. Go to the bottom specification, similarly select mole fraction of a component. Now here select toluene. Again go to the window and type 0.99 and enter it. Now this will simulate the column for the condition that the mole fraction of benzene on the top should be 0.99 and the mole fraction of toluene on the bottom should be 0.99. Close the window, save, close and run the simulation. The simulation has run, and as we can see in the stream report, in the top stream the concentration of benzene is 0.99 and in the bottom stream the concentration of toluene is 0.99. Now let's double click on the distillation column, click Edit and open the ChemSep interface. Let's look at the flow profiles, and as we can see here, the boil up ratio and the reflux ratio now has changed. The reflux ratio now is 2.8 and the boil up ratio is 2.41. We can view the other graphs and informations as indicated earlier, but an interesting thing here would be to go to Analysis, go to Phase Diagrams and goes to Binary. Here benzene is the more volatile compound and toluene is the less volatile compound. Now the type of graph that we want is XY plot at a constant pressure. The phases are going to be VLE and the pressures for which we want the graph is going to be only 101, 325. Click Calculate and click Done. Now we have the XY plot. We can copy the plot and place it in any document. Or we can copy the data, which is an interesting thing we can do, and put it in any spreadsheet. There we have the data on the spreadsheet now. Now this is the XY data on the spreadsheet. So that's an interesting thing that we can do. So let's close it. Finally, let's save it. And now we are done with the benzene toluene distillation. Hope you have enjoyed this lecture. If yes, do subscribe my channel. And yes, do share this video with your other friends and colleagues who would be interested in this and learning Cape Open Simulator and using it professionally. And ask them to subscribe it. You will find a lot of videos in the playlist which will help you in using this simulator. Goodbye friends. Have a great day. Have a great time.